going for an electroanalytical technique again from electrochemistry. So today we'll be doing discussion regarding the determination of activity coefficient and how we can do that experimentally. Now theoretically it is very easy to define activity for anything, but what here today we'll discuss what happens when you actually need to apply it experimentally. Remember, the activity coefficient that we are looking for is your mean ionic activity coefficient, that is gamma plus minus. This is what we need to find. Okay, so now this is our electroanalytical technique and it is an application in which we are utilizing metal insoluble salt electrode, metal insoluble electrode in combination with your SHE or any other standard electrode that you know. So now let's move forward. So as we have stated, we are taking a metal insoluble salt. So first we set up a cell in which we are taking H2 gas HCl with some molar concentration M. Then we have our silver salt and the silver that is being deposited. This is our entire cell reaction. Okay, we have taken a normal electrode just like that we set up. We have added some AgCl on the electrode just in case. So if you look clearly at this cell, there are two portions. One portion is this one on the left hand side, which clearly indicates that this portion is anode for the reaction, while this portion right here, which clearly represents there is a cathode. There are no double lines we have added because there is no salt base requirement for this. So from the cell representation I can write that the H2 gas that I have here, that we are injected, it will decompose on the electrode on the platinum and will convert to H plus ion with some molar concentration and add it to the solution, removing one electron. Now always remember, for insoluble salts you can never write this kind of decomposition reactions, that it is going for Ag plus and providing you Cl minus with some concentration M. You cannot do that. Why? Because metal soluble salt, insoluble salts, they have very low solubility in any kind of solvent, so they never undergo decomposition like this. So to explain their decomposition, we use a different method which is called as electron drop method, in which the electrons that are produced, they are dropped on the metal salt and this electron breaks off the salt into solid silver and Cl minus ion. Now looking at this, if you add both of these equations, I can write the overall reaction for this, which will be half of H2 at some pressure P, gas with AgCl present as in solid state. Then we have H plus ions, some molar concentration, Cl minus, some molar concentration, and Ag as solid state. So since we need to find activity coefficient, we need to utilize activity. And the best equation where we can utilize activity of any species is using Nernst equation. According to Nernst equation. Now, if I start writing this, it should look like this. EMF of a cell would be E naught of cell, standard potential, which we already know by theoretical measures, minus 0.0591 if the experiment is conducted under standard condition, taking n value equals to 1 because the electron transfer here is 1 mole of electron. Based on different type of cell you are working with, the n value here can vary. Now log of concentration of product upon reactant. So product are H plus ion, Cl minus Ag, and reactants are H2 and AgCl. So here I can write activity of H plus ions multiplied with activity of Cl minus multiplied with activity of Ag divided by activity of, not activity, pressure of H2 power raised to stoichiometry and activity of AgCl. For solid species, the activity always corresponds equals to 1. So this value will be equals to 1 and this value will also equals to 1 because both are in solid state. Now at 1 atm pressure, which we can control easily, so here this P will also corresponds to equals to 1. So in the final equation, what I'm left with? I'm left with EMF of cell, which is E naught of cell, which again we already know 0.0591 log of activity of H plus can be represented as mean ionic activity coefficient of cation multiply its molarity multiply mean ionic activity of anion multiply its molarity. Now when two activity coefficient multiply, they will give you mean ionic activity coefficient, or simply square of it multiply m square, taking square power common and bringing it to the front side. EMF of cell, it will become E naught of the cell minus 0.0591 using the properties of the log, that log a power is to n can be written as n log a. So I can write it as log, finally doing the final conversion, whatever the EMF of the cell that you can measure using galvanometer or any other method, and the standard value of E naught, which we already know from theories, this will become 0.0591 multiplied by 2 log of mean ionic activity coefficient multiply concentration. Now this is also the thing we can control. E of cell and E naught of cell both can also be provided to it. So putting in the values with this equation, the EMF of the cell or the mean ionic activity coefficient that you find will be given by 0.1182 log of mean ionic activity multiplied with their concentration. So in this equation, everything can be measured using experiment or via from theory, or simply can be calculated by us. So this is a constant value. This can be measured using instrument, and this is the concentration that we can calculate on our own, while this is the mean ionic activity coefficient. Ionic activity coefficient. So by rearranging the equation, we can find the value of mean ionic activity coefficient, which in normal cases is very difficult to find. So using Nernst equation, you can utilize Nernst equation in multiple scenarios and get different types of properties like current measurement, resistance measurement, voltage measurement, and like in this case we are looking for the mean ionic activity coefficient. So I hope this would have cleared your doubts regarding how to measure mean ionic activity coefficient experimentally and how Nernst equation is useful for it. Okay, in case of any doubt now, you can add it to the comment section and we'll get back to you. Or if you have any other suggestion that you want a particular video to be made in a like any specific context, you can just also add it to the comment section. Now till then, that's all for now. Thank you for joining us.